In our first video, we began discussing what a function is. We looked at the definition of a function and saw how we could calculate certain values by sort of plugging numbers in. We were looking at this function, this piecewise function specifically, seeing how we can compute, let's say, f of 0, f of 2. How do you do that for a piecewise function? We're going to take this a little bit further. In the second video, we're going to begin sketching this and then trying to answer all kinds of questions based off of that sketch. So let's go ahead and sketch this graph first. The way that we can do this is the following. So just imagine we have a piecewise function. There's three pieces here. Okay, so let me go ahead and start at the bottom here. So recall that f of x represents y. So I'll go ahead and call this y1. So y1 equals 1 minus x is the graph of our first piece. But this is only valid if x is between, or if x is less than or equal to minus 1. So that's what y1 is going to look like. Okay, so let's go ahead and create a grid. So we're looking at x values of -1 and less. So like these x values here in particular. Now, what we want to ask ourselves first, what kind of equation is this? Well, this appears to be a line, right? This appears to be a line. What are ways of sketching the graph of a line? Now, if we were only interested in sketching the graph of this line, you might use the slope-intercept method, or you might find the x and y-intercept, that particular method, to quickly find the sketch of a graph. But in the context of a piecewise function, we're going to plug in 2 points. We're just going to plot 2 points. The reason being is we want to know what happens right where this piece sort of stops. So we want to know what happens at x equals -1, and then just any other x value in this sort of over these x values here that are less than or equal to -1. So I'm just going to use -2. So if we plug this into the function, if we plug -1 in, we would get out a y value of 2. If we plug in -2, we're going to get out a y value of 3. So let's go ahead and plot those. So it looks like we have to go at 1, 2, 3. So at -1, we're at 2, and then at -2, we're at 3. Right there. And since this portion of the graph is valid for x less than or equal to -1, we're going to include this endpoint. So there's actually a point here. And then you just kind of connect the dots because this is a line. So this is what y1 looks like, our first piece. There. This is what y1 looks like. Okay, so let's do the second piece. The second piece, y2, equals 2 is the equation. And this is valid for x values between -1 and 1, not including -1, but including 1. Again, we ask ourselves, what kind of equation is this? Well, this appears to be an even easier line than we had before for the first part. It's a horizontal line at a height of y equals 2. Now, we're going to include -1, the y value at -1, which means that this point is going to be included here, and it sort of coincides with the other piece where it left off. However, when we get over here to the other x value of 1, or excuse me, I have that backwards. So at the x value of -1, we're not going to include that, but the height coincides with where we would be. So you would technically have a hole here, but that hole is filled in from y1. So you're just going to kind of extend this over. So that hole from y2 was filled in by y1. And then this is going to go over, and it looks like we're going to include the point right here at x equals 1. So this is y2. y2. Okay, and y3, let's see, so y3, y3 equals x squared. So again, we want to ask ourselves, so what is this equation? I don't think I want to put that there. I'm going to be running into myself here. So y3 equals x squared. All right, so where is this, or rather, what is this? This is a parabola, and we're only dealing with the portion of the parabola for x values that are bigger than 1. So it's just going to be the parabola over here to the right. Now, typically with a parabola, you would plot several points. You would want to plot a point maybe at the vertex if you can find it easily, and then maybe 1 or 2 points to the left and right of the vertex as well. But for simplicity here, just so that we start to develop the shape, and since we only have a portion of the parabola, we want to know what happens right at the break where it picks up at 1. Even though it's not included, we want to know where that is at. So we want to know what is the y value when x is 1, and then just maybe a couple others, 2 and 3, as long as they don't get too big. So we're going to plug that in. You plug in 1, you square it, you get out 1. You plug in 2, you square it, you get out 4. You plug in 3, square it, you get out 9. So let's see. So we have 1, 1, that's right here. There's actually going to be a hole there. And then 2, 4, that's right here. And then 3, 9 is a little bit too high. It's going to be way up here. So I'm going to kind of stop there. We know what this shape is going to be. It's going to kind of be this curve shape. And it's going up like that. So this is the graph of our piecewise function. So this is y3. Now, these 3 pieces all together make up the graph of f. And I'll go ahead and label the x and the y axes. All right, and just to be clear here, so this hole from y2 was actually filled in with the point by y1. So this is actually filled in right here. This hole from y2 was filled in with the point from y1. We have a point here, but now notice that we have a point here and then a hole here below. But that's okay. Now we can answer all of these remaining questions fairly easily now that we have the graph. Like, for example, what is the domain of f? The domain of f is all of the x values that you see on the graph. Well, if you go from left to right, just following along the graph, all x values are represented. You may say, well, what about this hole? Well, if you look above, there is an x value here at 1. So the domain is all x values from minus infinity to infinity. We're going to use interval notation for this. Okay, what about the range? What's the range of f? What are all the y values represented? Now, these were the x values in part B. The y's represented on the graph, well, it looks like starting down low, as low as we can go, would be at 1. So from 1 all the way up to infinity, the y values are represented. We're not going to include infinity or negative infinity, just like we had in the previous part. We're also not going to include 1 because there's actually a hole there. There's nothing there. These are the y's. Okay, on which intervals is f decreasing? Okay, so this can be a little bit tricky just in terms of what this is asking for. It's pretty easy once you understand what it's asking for. But so here's how we figure this out. So on which intervals, this is asking for which x values on the graph of f are the corresponding y values decreasing. Well, it looks like the answer is we want to look at y1 is the portion. So what are the x values there? It would be from minus infinity to minus 1 would be the x values over which this portion of the graph is decreasing. The y values are decreasing when you're reading it from left to right. Where is it increasing? Well, it looks like you have to look on y3. The x values there would be from 1 to infinity. And then finally, on which intervals is f constant? Well, it looks like in the over y2, that portion. So it looks like from minus 1 to 1. Now notice that you may be tempted to say, well, why didn't we include or put a square bracket around minus 1, which means you can include minus 1? Because it was technically decreasing all the way down to minus 1. Well, this is because if we look at what happened here at the break from y2 to y3, between y2 and y3, you may ask yourself, well, should I include this one? Do I not include this one? Just to leave any of that confusion out, especially when there may not even be a point at any of these, the convention is that we actually just use these parentheses where we don't include the endpoints. Because what does it mean anyways to decrease all the way up to -1, including -1, as opposed to not including -1? So we always leave these as just kind of open intervals or parentheses. All right, let's go ahead and work out another example. Now, again, in this section here, we're just kind of practicing some review material. We've also talked about, or you should have seen the absolute value at some point in like a algebra or pre-calculus course. This is the definition of the absolute value. It is a piecewise function. Now you may say to yourself, so what does the absolute value do? And the common answer is that it just makes everything positive. So the absolute value of 5 is 5, whereas the absolute value of -5 is also 5. It just makes things positive. Well, how does it make things positive? It does so through this piecewise function. And this is going to be important as we get into calculus. We're going to have to be able to use this definition of the piecewise function when we get into things. So let's use that for 5 and -5, for example. So f of 5 would be the absolute value of 5. And you have to ask yourself, so which piece does it go in? Which piece does it belong in? Well, it belongs in the top piece because 5 is bigger than or equal to 0. So when you plug it in, you just get out 5. F of -5, on the other hand, is going to go in the bottom piece. So this is the absolute value of -5. This goes in the bottom because -5 is less than 0, right? So when we plug it in to that piece, it's going to be -5, which gives you out 5. So that's how the absolute value works. Now we're going to do the same thing here with these two numbers. We'd like to be able to rewrite this as an exact number without an absolute value. Now let's first just see what this is approximately. So 6 minus 2 pi. Now if you remember from your pre-calc or trig class, pi is 3.14 approximately, and when you double it, you're going to get 6.28. Oops. 6.28. So this is for part A. Okay, so we know what this is going to be. This is or I should say that this is approximately, so I'll use these squiggly equal signs. So 6 minus 6.8 is negative 0.28. So that means it belongs in the bottom piece, right? And if it belongs in the bottom piece, to undo the absolute value, what you're going to do then is you're going to take minus that number. So as an exact number, here's how we can handle this. Since it goes in the bottom piece, here, let me just go ahead and do it with the approximated value first. It's going to be minus 0.28, which turns out to be 0.28. So that's what you would do if you're rounding things off. But we don't want to round it off. We want to keep this as an exact number. So it's going to be minus 6 minus 2 pi. Just following this because that's what the bottom piece tells us to do. You put a minus in front of it to drop the absolute value. Well, let's just go ahead and distribute this minus in. If you distribute the minus in, you're going to get minus 6 plus 2 pi. Or, if you'd like to write this differently, you can write this as 2 pi minus 6. So this is what that number is as an exact number where you're not rounding it off to say 2 decimal places or 10 decimal places. At this point, you can type this number into a calculator or a computer and get as many accurate decimal places as you want. The choice was not made for you already. Okay, let's go ahead and do part B. If I can erase here. Alright, so for part B, we'd like to do the same thing. Let's see. So the square root of 125. Well, we know that the square root of 121 is 11. So the square root of 125 is going to be bigger than 11. So this might be, I'm not going to type this into a calculator, I'm just going to say maybe it is, let's say 11.1 or something like that. So what do we have here? So we have 11.1 minus 11 in absolute value, which is roughly 0.1. So it's going to be roughly that. And from what we have here, and so this belongs in the top piece, which means that when you plug 0.1 into the top piece, you just get out 0.1. So this tells us, therefore, so this is just kind of some scratch work. This tells us that the square root of 125 minus 11, when we're taking an absolute value, it's going to go in the top piece, and we just drop the absolute value because it's already positive. And so here's how we work with the absolute value, and we kept this as an exact number. All right, we're going to go ahead and stop here with this video. If you'd like to practice some of the WebAssign homework problems, I think you're ready to do problems 1, and maybe you can give number 2 a try from the WebAssign homework assignment.